Hello friends, in this video I'd like to solve the following problem from the Balkan Mathematical Olympiad 2016, shortlisted problem A8. Sadly I do not know the author of this problem, and I do not know the country of origin of this problem. If you happen to know, if you have a source, please let me know in the comment section. We wish to find all functions f from the set of integers into itself, for which this expression f of g of n minus g of f of n is independent on n for every function g from the set of integers into itself. It's a nice problem, not very complicated, but you have to do some guessing. Here are my hints. It's all about considering proper functions g. First, consider g of n to be equal n plus 1 for all n, and test for what functions f this expression is independent on n, and then consider second function g of n which equals n squared, and that should be sufficient to determine function f. And also keep in mind that if the difference of two terms of a sequence is constant, then the sequence is arithmetic, which means that f of n equals dn plus f0 for all integers n, where d is some constant given first. So give this problem a try. Alright, so I wish to consider first, let g of n be defined as n plus 1 for all integers. And let's consider our expression f of g of n minus g of f of n. Well, f of g of n is f of n plus 1, and g of f of n is f of n minus 1. And remember that this should be independent on n, so it's a constant. So it's a constant, which means that our sequence f of n is an arithmetic progression. How do I know that? Because the difference of two consecutive terms is a constant. We can put 1 on the other side, we still have some constant. i.e., well, it can be written that f of n equals dn plus f of 0. So for some constant d, there is a constant d such that this holds. Alright, so now it's just a matter of finding d and f of 0. And to do that, we will consider second function. Now, let's consider g of n, which equals n squared for all integers n. Then we have the following. Well, f of g of n minus g of f of n should also be a constant, and let's write it. What is f of g of n? It's f of n squared, and here we have f of n squared. But what is f of n squared? It's dn squared plus f of 0 minus, and here we have dn plus f of 0 squared. So we have dn squared plus f of 0 minus d squared n squared minus 2d f of 0 n minus f of 0 squared. And let's group our terms, and we will have d minus d squared, or d 1 minus d times n squared Yes, these two terms. Then we will have minus 2d f of 0 n minus 2d f of 0 times n. And finally, we have plus f of 0 minus f of 0 squared. Alright, and remember that this whole expression should be a constant as well, should not depend on n. But here we have a polynomial, a quadratic polynomial, which should be constant. So the only possibility is that every coefficient standing with n must be 0. So we must have the following: d1 minus d equals 0, and we also must have df of 0 also equals 0. And we have two possibilities. Well, either d is 0, so either d is 0 and both conditions are satisfied, or the second possibility is that d equals 1 and f of 0 equals 0, the second possibility. So we have only two functions to consider. The first possibility really says that f of n equals f of 0, it's a constant function, and the second possibility says that f of n equals n, it's the identity function. And let's just do verification. Verification. Well, so fix any function from the set of integers into itself. Then we have the following: f of g of n minus g of f of n. For the first possibility, it's what exactly? It's just f of 0. F of 0 minus g of 0. G of f of 0, sorry. G of f of 0. So it's independent on n. Independent on n. So it's verified. And now let's do verification of our second function. In this second case, f of g of n minus g of f of n. Well, our function is identity, so we have g of n minus g of n, which is 0, obviously also independent on n. Which is all well and good. So we have just two solutions. These solutions, not just two solutions, we have infinitely many solutions. So these solutions, either our function is constant, where c is really any integer whatsoever, doesn't matter, or our function is identity function, f of n equals n. And that closes our problem. So yes, thank you very much for watching. I hope that you've learned something new this time, and I will see you next time. Goodbye.